Alright, we're going over the solution on this problem. 5.5 times 10 to the 14th, that's what we got. Notice you get 2 points, one for basically trying to use the equation, that's kind of a pity point. 1 point for the correct answer with correct units.
Oh, oops.
So if you wrote down 5.5 times 10 to the 14th and you didn't write down hertz, sorry.
I hope it
Alright,
hurts.
now it's not always that way in the scoring guide. But that's a 10-pointer. Write down your units, slackers. Alright, now it says for writing one or more of the equations that can be used. Alright, so we use the small angle approximation, or d sine theta equals m lambda, or basically all those cases to derive the equation. For indicating that the calculation is for the spacing between the fringes rather than the position of a single fringe. Alright, so basically that was worth a point. See what I'm saying? Now, even though the answer is exactly the same, we needed to say that the distance between the two dark fringes is the same as the distance to the first fringe. The grader wants to know that you knew that. And so that was basically a point. Adjacent fringes means m, or delta m is 1 because the distance between the spaces. Well, you would indicate that by saying that, by writing out what we wrote out, so you would get that point. And it's 0.0067. We got 6.72 times 10 to the negative 2. Same thing, didn't we? Okay. They only carried it to 2 sig figs. We carried it to 3. For indicating the frequency is the same, a point. And then frequency, you get that. If there's no answer in part A, and the calculation was done, the scoring guideline. So basically, if you didn't know how to find the frequency up there, but for some magical reason you can find the frequency here, then if they saw you write v equals f lambda here, and you left the first one blank, you can at least get a point here. We said decreases, right? For indicating that in the explanation that the wavelength decreases. So basically all you had to say, we said, okay, as the index of refraction increases, the speed decreases, which means the wavelength decreases. But all you had to do is say the wavelength decreases, and then show the equation. If the wavelength decreases, then, basically the spacing is also going to decrease as well. And that was worth 3 points. Pretty sweet question, wasn't it?
No,
All right?
not at the time.
Yeah, it's very sweet. All right, while we're still on camera, let's see if we can look at another one. And click like on Facebook.
Do we have to?
Yes, we have to. Okay, let's look at the other free response. 2005. If you look at 2005, I can just pull that one up somehow. Oh, I guess I can't. All right, y'all have a nice... Well, wait, we got a little bit of time. If I'm supposed to have hall duty, I don't know what my hall duty's for. I guess I'm taking tests up here at the waste of my time.
Oops.
Can I, talk to you on the walkie-talkie or something?
Yeah.
Alright, well,
Just keep talking into the iPad.
yeah, I wish I could, this next one is actually, how do I do this one? Alright, this one is one of those, if you understand the idea, though, it's really easy. Your teacher gives you a slide with 2 closely spaced slits on it. She also gives you a laser with a wavelength of 632 nanometers. The lab task you're assigned asks you to determine the spacing between the slits. These slits are so close together that you cannot measure their spacing with a typical measuring device. Okay? From the list below, select the additional equipment you would need to do your experiment by checking the line next to each item. So what experiment would you set up?
The youngest double slit.
Alright, so you'd set up an experiment where you're going to have a screen, right? You're going to have a, whatever your slide with the 2 slits on it, we'll draw that like this. Here's your slide, but that's way not drawn to scale. And so you're going to shine the laser through this right here, and then you're going to get the patterns. So what would you need if we're going to use, you think you could use a small angle approximation now?
Yeah.
I think you could. So what was that equation? XM over L equals what?
Approximate.
M sine of theta over
D.
D? So I'm trying to find L, aren't I?
You wouldn't use the sign of theta.
Oh,
It would be
Yeah.
m lambda.
For this?
oh, what's the equation? I'm not writing it down right.
It's
Okay.
x of m over L equals.
X of m equals, I just write it from the m lambda L over D. All right, there you go. So you're going to need to figure out the wavelength. Well, they gave you the wavelength, so that's given. M is the first fringe. How are you going to figure out where the bright spot is?
A light intensity meter.
A light intensity, oh, backwards check. All right, a light intensity meter. How would that work?
It would measure the brightness.
Right,
And
if
then,
you knew the brightness here in the middle, right?
right.
Then you moved along. It's kind of like when we walked along, and the farther we walked, the louder the sound got. If you take this and you have the brightest spot here and you move it up a little bit, right?
Mm-hmm.
It's going to be brighter. So I definitely want that.
What about the large screen?
Let's see.
You probably
We need to hold the slide, right?
Yeah.
possibly.
You need to have a screen. What else? We have to have some way to measure this distance from here to here. And we have to measure the distance from here to here.
A meter stick.
So,
And possibly.
well, but I would say the tape measure to go from where to where?
From the screen to the slide.
I'd use a tape measure from here to here, and then from here to here, I would use the,
Meter stick.
I don't know, maybe a ruler. Because it's not going to be very far, is it?
No.
And you get a better reading with the ruler. Okay, now it says on the graph axis below, sketch a graph of the intensity versus position that will be produced by your setup. Well, the intensity versus position, basically it's going to be brighter in the middle. As you go farther away, it's less bright. So what you want to do is you want to just draw bright in the middle and then farther away. And basically, the way I already saw the scoring guide, they're going to look for a bright high in the middle, and then as you go farther away, they want symmetry. It basically gets weaker as you get farther away. Outline the procedure you would use to make the needed measurements, including how you use each of the pieces of the additional equipment you checked in A. So you'd basically say, I would use a slide holder to hold the slide, right? I'd set a screen up a distance away. I would measure that distance with a tape measure. I would shine the laser through the screen, and it would form a pattern on the screen. And I would just talk through all the things you needed in that equation. I would find the central bright spot by the intensity meter. Then I would slide it, to the left of my screen, or to the right, and I would look at the next bright spot, light intensity, where the next part was, and then I would plug it in and solve it. It's a really simple problem.
On stuff like Part C would be acceptable to write on there. This is supposed to be symmetrical or something.
You could if you can't draw very well. You may want to do that. Well, then it says, using equations, show explicitly how you would use your measurements to calculate. So basically, outline the procedure. Well, the procedure would be guided by your equation anyway. So you can't really do D without knowing E, can you? And then I would just show them the equation I would use. And I'd say I'd solve this equation for D. And it's that simple. Now, the only other things you have to go through, because I have to go sit in the hallway for 3 hours, or 2 hours, is there's some multiple choice questions, but there's some stuff here on, it's called thin film interference. And that's something we could go over. Sometimes it shows up, sometimes it doesn't. It's kind of a risk. It's really not that tough of a concept, but I just don't have time to do it now. But what I want y'all to look through is I want you to look through this. You can read through this first section. Those at home who have this packet, you can get it from me.
30 seconds.
And you can also go through the free response. There's a free response here. And I have the answers to these. I just didn't put it on here. All right. Thank you. Have a nice life.